Hi guys, welcome back to my math YouTube channel. Let us look at example number 3 now. Guys, in this case, we have a ratio of two complex numbers and we want to simplify it, and finally we want to get it in an a plus ib form, which means we want to get it in a standard form where we can identify the real part and the imaginary part. Now guys, for this particular example, I'm going to show you two methods of actually simplifying this. One will be to transform this into a trig form or a polar form and then take the ratio. When we do that, we have to use some other identities that we have learned in the prior videos. And the other method would be just directly simplifying it as it is, okay, from the complex number. Guys, let us start with the simplifying this from the standard form, which is it is already provided in, and then we will also look at the trig form, how to convert it into the trig form and then simplify that. So first of all, in order to simplify the ratio of two complex numbers, we already know we have to multiply by the complex conjugate of the denominator, and that's what we are going to do here. So I start by rewriting this complex number 1 plus I over 1 minus I, and then times, we're going to multiply by the complex conjugate, and the complex conjugate of the denominator will be 1 plus I. Guys, keep in mind, whenever we are simplifying the complex numbers, we got to multiply, and when they are divided, we have to multiply by the complex conjugate of the denominator. That's how we are going to be able to get rid of the imaginary piece in the denominator, and then we can write it out as in the standard form where we have a real part and an imaginary part, basically, which means that we can kind of transform it into a real and an imaginary piece. So it's going to be 1 plus I right here. Now let us simplify further. Simplifying further, this would mean we can distribute it. It's going to be 1 plus I plus, so I like to draw those arrows. One again, I, and I times I is I square. So I'm going to write that I square here. And in the denominator, when I multiply everything out, it's going to be 1 plus I minus I and negative I square. Guys, if I simplify further, this is going to be 1 plus 2i, I plus I is 2i, I square is negative 1. We already know that basic identity that I equals to square root of negative 1. And when you square I, we'll get a negative 1. Then divided by downstairs, this and this will cross out. I'm only left with 1 minus I square is negative 1. So I'm going to put it in the parentheses. Simplifying further, guys, this 1 and negative 1 will cross out. I'm left with 2i. And downstairs, this negative negative becomes positive. 1 plus 1 is 2. And this 2 and 2 crosses out. We are left with I. So that would be the final answer. If you want to write it in the standard form where we can see the real part and the imaginary part, guys, then we can rewrite this as, and that's how we should actually rewrite this, 0 plus 1i. Now from here, we can say that the real part is 0 and the imaginary part b equals to 1. So guys, this is one of the ways to actually simplify this. And in this case, I think it is easier to simplify it like this, just by multiplying upstairs and downstairs by the complex conjugate of the denominator. Now at the same time, we also want to see how to actually simplify this by transforming it first into a trig form and then simplifying. So guys, first of all, we have to rewrite the numerator in the trig form or a polar form and the denominator in the polar form. So guys, let me look at my notes and see what I have here. So guys, first of all, I have already showed you many different examples where we transform from a standard form to a polar form. So you can go back, and if you want to know about all the details. Here, I think I can, well, let me go ahead and try to give you some details here as well. Guys, quickly, this guy, let us start with 1 plus I. So for 1 plus I, if we want to transform this into a trig form, we know the corresponding trig form is going to be R times cosine theta plus I sine theta. So we need to find the R, which is the absolute value, and then we also need to find the angle theta. Guys, it is not too complicated. All we have to do is, for this, we have to identify the real and the imaginary part. What is the real part? The real part is just 1, and the imaginary part here is also 1. So A is 1 and B is also 1. We're only first working with the numerator, and then guys, we also have to do the same thing with the denominator. So real part is 1, imaginary part is also 1. If I have to plot this, guys, obviously it is going to be in the first quadrant, somewhere right here, right? And then if I draw a right triangle here, this is going to be my reference angle. This is my 1, this is my 1. First of all, let me go ahead and find the R. Guys, R will be square root of 1 square plus 1 square, which is also the hypotenuse of this right triangle, so it would be square root of 2. So R is square root of 2. We already have the value for R. Now let us go ahead and write the values for cosine and sine. So guys, cosine of theta will be 1 over radical 2 because it is opposite over hypotenuse, but we have to multiply, or we have to rationalize the denominator. When I rationalize the denominator, we get radical 2 over 2. Guys, same thing for the sine theta, we get 1 over radical 2. Rationalizing again, we get radical 2 over 2. That means for sine and cosine, we have the same values. Now it's in the first quadrant, right? Since it's in the first quadrant, guys, I'm going to look at my unit circle and I'm going to identify the angle for which both the cosine and sine values are radical 2 over 2. And clearly we can see that that is true for angle theta equals to 45 degrees. So what does that mean? That means we have the nice trig or polar form which looks like this, radical 2. And then inside the parentheses we have the cosine of 45 degrees plus I times sine of 45 degrees. Guys, that is the trig form or the polar form of the numerator. Similarly, we have to find the trig form or the polar form of the denominator. Let us go ahead and try to figure that out. Guys, I'm going to preserve this because we already figured this out so that we can verify that we get the same thing by using this other method, okay? So I'm going to get rid of this. And now let us see what we can do with the denominator. Guys, I got rid of the denominator, but I know it's 1 minus I. So I'm going to bring it back. I think I also need a different marker here. I'm going to use a different marker. So now let us work with 1 minus I. Guys, to find 1 minus I, or to transform this into the polar form, not too difficult. We have to identify my real part, A, which is again 1, and my imaginary part, which is going to be negative 1 in this case. If I plot this, let us go ahead and plot it. If I plotted A1 and B negative 1 is going to be somewhere right here. And then the angle, well, we can think of a reference angle right here, but we know the total angle, actually angle which is measured from this reference side in a counterclockwise direction. So this is going to be my actual theta. And then my side is positive 1 and this is negative 1. And of course, we have to first find the value for r. We know r is going to be square root of 1 square plus negative 1 square. So r is still going to be square root of 2. So we have my r equal to square root of 2. Now we have to do the same thing. We have to write the values for the cosine and the sine. So let us go ahead and do that. Let me start with the cosine. The cosine of the theta we know is, in this case, guys, we kind of think in terms of the x, y, and r. Here it was fine. We could still think in terms of the opposite and adjacent, or you can still think in terms of x, y, and r is the same thing. Guys, here I'm going to write cosine theta is x over r. What is my x? X is 1 over radical 2. Same thing, we got to rationalize the denominator, so we get radical 2 over 2. Guys, I'm skipping some steps here because I have already done this so many times, so you may want to go back and look at those videos if you are not very confident how we get from here to here, but it's basically just rationalizing the denominator. Same thing we do with the sine theta. What sine theta is what is the definition for the sine theta in terms of any angle? It is the ratio of the y over r, and y is negative 1 over radical 2, which is the r, and we rationalize, we get radical 2 over 2, but there's a negative sign here. So this is in the fourth quadrant. We can already see that once we plot it, we can see which quadrant this is in. And to find that angle, guys, we are looking in that fourth quadrant where the cosine is radical 2 over 2 and sine is negative radical 2 over 2. And I can clearly see that it is going to be, the theta is going to be 315 degrees. So we have r, we have theta. What is my complex number in the denominator going to look like? It's going to look like z equals to radical 2 again. And then inside the parentheses, I have cosine of 315 degrees plus I times sine of 315 degrees. Guys, we have, let us call this z1 and let us call this z2 because these are two different complex numbers. Guys, we have transformed the numerator and denominator into polar form. Now we want to take the ratio of those. Guys, I'm going to get rid of some of this so that we can take the ratio. So I'm going to get rid of this. Now let us go ahead and set this up and try to find the ratio. So guys, this is equivalent to radical 2 times cosine of 45 plus I sine of 45 divided by, and then I have my denominator transformed as well, which is radical 2 times cosine of 315 degrees plus I times sine of 315 degrees. Guys, from here we can clearly see that the radical 2 and radical 2 just crosses out. And to take the ratio of a complex number in the polar form divided by another complex number in the polar form, we already know that we just have to subtract the angles, theta 1 minus theta 2. So if we think of this as theta 1 and this as theta 2, it's going to look like cosine of theta 1 minus theta 2, which is 45 minus 315. And same thing for the sine of 45 minus 315. That is something we already know from dividing any two complex numbers. So it is going to be sine of 45 minus 315 degrees. Guys, simplifying further, this is going to be cosine of 45 minus 315 is going to be negative 0, that's 270, and plus I sine of negative 270. So now we have to figure this out, figure the value of cosine negative 270 and sine negative 270. Guys, you can use a calculator for that, or you can look at the unit circle. So on the unit circle, since it is negative 270, so that means what we are doing, we measure angles. So because it's a negative, so we got to go clockwise. So from here, this being the reference side, we got to go this way. To get to negative 270, we have to go all the way up here. So basically negative 270 is coterminal with 90 degrees. So we're basically looking at this value right here. What is the value for cosine of 90 and sine of 90? Guys, cosine of 90, I'm going to write that from looking at my unit circle. So cosine of negative 270 is going to be 0 plus I times sine of negative 270 is 1. So it's just going to be 0 plus I, which is also equal to just simply I. But if you like to identify the real and the imaginary part and you want to rewrite this or write this in a standard form where one can clearly see the real and the imaginary part, then I would leave it like this. This being my real and this being my imaginary part. And guys, that is exactly what we have here if we just simply multiply by the complex conjugate. So guys, I know this is the easier way. By just simply directly multiplying, it's quicker. This takes more time, but one has to know how to transform these into trig forms and then simplify. Guys, in the textbooks, sometimes they clearly state that you have to first transform these into the trig forms and then you have to divide it. If your problem is very specific about that, then one has to transform into the trig form and then take the ratio. Otherwise, guys, if the problem does not tell me what I'm expected to do, I'm going to use the easiest and the quickest way to actually simplify or solve this. Okay, so guys, please, try to use the method that you like or whatever is convenient to you, based on the problem. You have to see what the problem is asking, right? So guys, these are two ways of simplifying this. This covers multiplication, division. Now in the next video, I'm going to start talking about the powers of complex numbers, which is also based on multiplying two complex numbers, but we will be looking at the trig form or the polar form.